This is the short version of practice problem number 3 from lesson 9, Moves in Parallel, and unit 1, Rigid Transformations and Congruence. In practice problem number 3, you have points P and Q that are plotted on this line, and you are asked to find point R, which is the center of rotation, which takes P to Q and Q to P when each are rotated 180 degrees around the center of rotation at point R. And then B is there more than one point R that works to send P to Q and Q to P? I'm going to show you 3 different points and what happens when you use each of these 3 different points for a center of rotation. One is the midpoint between P and Q. So I'm going to label that R, that's the center of rotation, and it is the midpoint. The second point to look at is when R, the center of rotation, is not at the midpoint. So I moved R down here. It's still on the line. Still going to rotate 180 degrees around the center point R, which means that P to P prime is going to land on the line, and Q to Q prime is going to land on this same line. And the third point is the center of rotation that is not on this line. So I placed that center of rotation out here, and again labeled it point R. The first example is when R is at the midpoint. So the center of rotation is at the midpoint. And what happens in this case is that this distance from that center to Q is the same distance as that center to P. So in other words, this line segment PQ is the diameter of this circle. So therefore, when you send P 180 degrees around the center of rotation, it's going to land back on this line, and it's going to land right at Q. And Q is going to rotate 180 degrees around this circle and land back on this line at P. So PR is the same distance as the radius of the circle, and QR is also the same distance, is also the radius of the circle. When R is at the midpoint, a 180 degree rotation answers the question. Q lands at P, and P lands back at Q. Now when R is not at the midpoint, these distances are different. So PR is a different distance than QR. So if I draw circles, this circle has a smaller radius. So this is P to P prime. So when P rotates 180 degrees around this center point R, lands at this point, which is what I'm going to call P prime. And likewise, when Q rotates 180 degrees around that same center, this distance is different. This Q to R is a different radius than P to R. So this circle is larger, and so Q is going to rotate 180 degrees and land at Q prime. So when the center of rotation point R is not at the midpoint, then P does not land at Q. It lands at P prime, and Q does not land at P. It lands at Q prime. So this point does not work. It does not send P to Q and Q to P. And finally, when the center of rotation point R is not on this line, then Q is going to rotate 180 degrees around R. It's going to end up down here somewhere. And P is going to rotate 180 degrees around point R. And so it's going to end up here somewhere. So neither point is going to rotate to the other point when rotated 180 degrees. So QR, this becomes the radius of a circle. It's an equal distance on the other side to find Q prime. And you can draw a circle and see that rotation. Q goes to Q prime around point R. And P, this is the radius of a second circle. So PR is an equal distance on the other side to get to P prime. And you can draw that circle. So P rotates 180 degrees around the center point R and ends up at P prime. And this line, the entire line, rotates 180 degrees and forms a parallel line to PQ, which is P prime, Q prime. And to see that rotation a little bit better, Q travels along the pink circle to Q prime, and within this same triangle, P travels along the blue circle to land at P prime. So you can see that this blue triangle rotates 180 degrees around the center point R and ends up positioned here. So this side is parallel with this side. Q to Q prime forms a straight line, and P to P prime forms a straight line. Now you can add to this the midpoint. So the midpoint is an equal distance from the center R. So you go to the other side, And that midpoint between P prime and Q prime is right here. And so you can draw its third circle. Call this point M. M rotates 180 degrees to M prime, which is the midpoint between P prime and Q prime. So it takes three circles, three different points, Q, M, and P, to find their corresponding points that are rotated 180 degrees. In the first example, it only took one circle, P to Q. Both points are on the same circle, rotates 180 degrees from P to Q and from Q to P. And the second example, it took two circles because these 2 points, P and Q, are different distances from R. So it takes two circles to rotate 180 degrees to find the corresponding point. So P to P prime and Q to Q prime.